Good morning, good afternoon, and good evening for all the audience worldwide. I'm beyond thrilled and happy to be in 2024's first session of the Android Worldwide. It's my first time here, and I will talk about building Android quality apps for the future with continuous integration. Um, a little bit about me, like David introduced me here. My name is Aline Ayres. I'm currently lead mobile developer Android specialist at Totox, and I've been working in the technology area for 14 years. I started as a web developer, and I love to work with Android development, and I started with in 2012. Um, Currently, I've been working as tech lead, and I'm Brazilian from a city called Recife in the state of Pernambuco. But today I'm doing the presentation from Santiago in Chile. And also I'm a mother of a very cute 5-year-old boy called Theo. Let's start here. I brought an agenda just to prepare or just to present what I intend to do here. And I want to talk about what is continuous integration and continuous delivery. And I brought the basic concepts of CI and continuous integrations, workflow. We're gonna deep dive into the how to build a workflow and the CI benefits, the types of automation we can do to assure very good CI pipeline, automation tools, and why everything that we're going to talk about is important for the mobile world in this term called mobile devops. And I brought a small conclusion to finish this presentation. And what is CI/CD? And continues to explain more about the autonomous continuous integration and continuous delivery. This is not very new. It's not new. It's not a new concept because it's a software software development practice that was created in the 90s, and where each member of a team merges the changes into code base together with their team peers, at least daily. So each of these integrations is verified by an automated build, including tests, to detect integration errors as quickly as possible. Teams, in my experience and experience worldwide, this approach reduces risks of delivery delays, reduces efforts, the effort of integration, and enable practices that foster a healthy code base for rapid enhancement with new features. I would like to mention Martin Fowler because he's the main reference on this topic. And recently, I brought this link here. He updated a very complete article about continuous integration written in 2001, and that's why I talk about it's a practice with 20 years old of evolving and helping teams to confirm the value of the continuous integration. So here I brought a diagram that shows how continuous integration and continuous delivery are kind of the complementary process or practices. In the continuous integration, you can see that all the things start with the planning, and after we planning what we're gonna do, we as developers we're gonna code the software, and after that we're gonna build and test and release. And when we start to release, we begin the process of continuous delivery when we deploy, and after that we're gonna operate the release of the software, and monitor all the things that we are delivering to production and start all the cycle again. So with the continuous integration, it's focused on the cycle of the development integration with the main line in the team's development environment. And the aim of continuous deliveries is that the product should always be in the state where we can release the latest build. This is essentially ensuring that the release to production is a business decision. So these two processes, for me and for the community, is complementary to deliver a very good software. And we also have another acronyms with the CD that is continuous deployment. It causes a little bit of confusion for those people who doesn't know the difference, but I brought a very clear diagram here to explain. With continuous delivery, we have all the process automated till the staging environment. So we have a pipeline built to do the build of the application. After that, we have automated tests, and we have also the deploy to the staging environment. But the difference, like I said before, the deploy is manual to production. So this is a business decision to put the latest build in production in the case of the continuous delivery. Differently from the continuous deployment. Continuous deployment, it starts with the same process of continuous integration, and after that, the continuous delivery that I mentioned before. And the difference is that all the process that starts with continuous integration and continuous delivery, it also automated to do the deploy to production. So this is the difference. I hope you all get how clear is that, but we don't have we don't have this manual interaction or this business decision differently from continuous delivery. So in here, I brought some CI basics concepts to show you how the continuous integration works in teams. So we have a team with several developers that are doing changes daily, and they push the changes to the repository, and the CI system will be prepared to trigger a pipeline that is prepared to validate the integration. And after that, if your build is green, if your build pass to all the validations that I will explain the next couple of slides, your code go to the repository. So, and each push will trigger commit to be validated in the CI system, and after that, the code goes to a unique repository for all the team. If your change doesn't go well, and the pipeline validate found some error, we're gonna to revert this commit and correct the as fast as it can. So how does this our CY workflow works? I brought here sorry, I didn't mention this link here. It's a training that was released last year in Google Developer, in Developer Android page. It's a training explaining continuous integration techniques, and this is very well completed too. So the workflow here is very visual, and a typical CI system follows a workflow or pipeline, which might look as follows. The CI system detects a change in the code, usually when a developer creates a pull request, and also change list or merge requests. It depends on your Git strategy. And after that, it provisions and initializes a server to run the workflow. It fetches the code as well as tools such as Android SDK or emulator images if needed in case of mobile applications. It builds the project by running a given command. For example, for Android, we use Gradle to build. So we call build command from Gradle. After that, we gonna run the tests, mainly the unit tests, local tests, by running a given command also by Gradle too. And we can also evaluate our changes with the running instrumented test that I will talk in the next couple of slides. But we need to instrumented test. We need to start emulators to use the resource from device. So, and we can validate also instrumented tests. And after that run all the steps. It's not obligatory, but we can upload the artifacts and test results and APKs or bundles to our CI system after all the steps are running. And what's the benefits of CI? It's increase quality, improve quality of software. CI can help to improve the quality of software by identifying and fix problems early, and it can help to reduce the number of bugs in software releases and improve the overall user experience. It reduces the risk of broken versions. When you automate your build process with CI, you can better avoid broken builds by resolving issues earlier in the process. Also, it's increased the confidence in release for the developers and for the users too. And CI can help to ensure that each release is stable and ready for production, because it just the changes that are fit to the pipeline validation are going to production. And by running automated tests in CI, can identify any potential problems before you release them to the production. And it improves the communication and collaboration with the team, because the repository will gonna be the unique channel to your team to push the changes, and by providing a central place for developers to share code and test results. And CI can help to make it easier for developers and other team members to work together and track process. And also increase productive. CI can help to increase developer productivity by automating tasks that would otherwise be time consuming and error prone. And we need to all the things that I'm talking here, we need to automate all the process, as many manual processes we can in the pipeline. And that I'm talking about automation, I brought some types of CI automation that is basic for building a very reliable and strong pipeline. So the basic jobs we need to have uh, to do these pipelines for mobile apps, we need to start by doing the build to compile. By building the project from scratch, you can make sure that the new changes will compile correctly and all the libraries and tools are compatible with each other. So we build is a basic job you need to do. You need to have in your pipeline. Lint static analysis, linters or style checks. This is an optional, but I recommend this step. When you enforce style rules and perform static analysis, code review can be more concise and focused. Linters also can detect poor programming practice and ensure code follows a team preferred formatting style. And we can validate that to ensure quality of your applications. And run unit tests, or local unit tests, because they run on the local machine that performs the build. On Android, this is usually in the JVM, so they are fast and reliable. And we also can use, they include Roboelectric, we can use Roboelectric tests as well. Other jobs that we can run are instrumented tests. Instrumented tests are tests that run on emulators or physical tests, require some provisioning or waiting for devices to boot or to be connected, and other operations that add complexity. These type of tests are very heavy in the pipeline, and there are multiple options to run instrumented tests on CI. It can be managed by Gradle. You can use to define the devices to use. For example, you can use a specific pixel version with an emulator, with a specific API from Android, and it handles device provision. And to accelerate this process, because the creating emulators is, like I said, is a very heavy process for the pipeline, we can create steps to initiate the emulators. And there are CI systems that provision these for the pipeline to handle the creation of Android emulators. And also we can delegate instrumented tests to advice farms such as Firebase Test Labbing, Firebase Test Labbing, because device farms are used for their high reliability, and they can run on emulators or physical devices. Also, we have two more types of tests. There are regression tests and integration tests. These two types are also very heavy to run in the pipelines, but it's not a must-have, but it's very interesting to have in the pipelines. But we can build another pipeline just to run this type of tests in the other process, but it's interesting to validate in the continuous integration too. Because a regression test could take a lot of time in execution. And like I said, a good practice to run integration tests or regression tests is to have a nightly builds running after the continuous integration. And of course, we can count on tests to find everything. And it's often been said that the tests don't prove the absence of bugs, but however, perfection isn't the only point at which we get payback for self-testing building. We need to have a pipeline that is a self-test pipeline, because imperfect tests run frequently are better than perfect tests that are never written at all. And we have also test coverage. And a thing that's to consider with test coverage is it's a metric, it's not a type of tests that you run in your build, but it's a metric, and it should not only be the only indicator, because sometimes different type of coverage bring different metrics. So it's a very controversial automated steps in workflows, but it's very interesting to have a good practice to automating the verification of test coverage percentage reduction. And in my experience, I brought two automation tools to share with you all. It's very known by the Android community. It's the Gradle. Gradle is a fast and dependable dependency management, and Gradle build the slogan of the Gradle is to build anything, automate everything, deliver fast, and it's more productive for development. And Gradle is widely used and mature, and it is a mature tool and it's very used by the community. And Gradle has supports Android, Java, Kotlin multi-platform, Groove, Scala, JavaScript, and other languages too. I use Gradle to automate almost everything. And Fastlane. Fastlane, it's a tool. It's a tool also very easy to use. They have a lot of plugins to be used mainly for automated development release process. It simplifies Android and iOS deployment too, and it's an open source and it's extendable and customizable. So we can create lanes to handle all tedious tasks you want to, like generate screenshots, dealing with code signing of the apps, and releasing the applications to the store. So Fastlane is also very useful to do automations in your pipeline. And the CI tools, or CI systems, we can also call the CI systems. I brought the most known by the community, just to talk a little bit of each one. Bitrise is a very dedicated CI system for mobile. So if you want to try to test or to do in your project for production, just for mobile applications, you can do with Bitrise. Another one very well known is GitHub, because GitHub Actions, because it's integrated with the GitHub too, and others. I won't talk about everyone, but Jenkins is also one very used, but it has some problems with to build it, to create in iOS, to applications in iOS, but we can handle that too. And the other ones are very used too, but I won't explain all the details. And why all of this matter for the mobile world? Like I said in the agenda, the mobile DevOps, it's an area when we incorporate the set of practices with continuous integration with the mobile world, where you can adapt your app development process in these techniques of the DevOps, and to have a successful, or to succeed in the world of mobile. So why this is important? For mobile, we need to have, when it comes to mobile iterations, we need to have speed to do the delivery of the apps. So there is a strong correlation between the frequency of updates and the ranking in the app stores. The more agile the approach, the faster and more interactive the release process becomes. So the mobile DevOps practices increase the frequency of deployment as opposed to the older methods where larger portions of the code were deployed less frequently. The ideal and the ideal end result is a fully implemented rolling deployment system, and in other words, regular releases to a subset of users. This can be done for test purpose with either alpha or beta versions, or staged releases or kernel releases to multiple markets. Automating all the deployment pipeline reduces time, and it takes to roll out in new iterations, and enable teams to react faster to user feedbacks. And talking about user feedbacks, uh, apps users are less tolerant. So if your app have a problem with if your app have a bug or a problem with the user experience, the user of your app is gonna evaluate with worse, with a bad experience, or will dropping the 1 star in your application evaluation. So to avoid mistakes in mobile apps is more critical than it is in desktop apps. So pre-production tests becomes more important. Teams also need to closely monitor the feedback and ratings on app stores to keep up with future enhancements and continuously improve their apps. Mobile DevOps enables instant reports and feedback, as well as regression tests, like I said, and no to transparent process or an automated process. Mobile tools are always evolving, and the mobile app development are unique. Like I started this topic, and constantly evolving. From building to deployment and performance monitoring, there are always new technologies for keeping up with the ever-growing market's needs. The practice exists for different projects, platforms, programming languages, and so on. And staying up to date with all these is another challenge for developers. And mobile DevOps practice address these issues by automating more of the manual tasks and by implementing systems in which code configurations, scripts, documents across different platforms are easily trackable. And streamline the process helps teams adopt new tools and leave more resources for app development. And another point is that mobile has a wide variety of devices, and testing on several types of emulators, parallel tests, and tests on real devices can predict behavior of app on each platforms. So mobile as a platform is more fragmented. Mobile apps go through increasingly rapid development process, which results in more and more releases ending up on different devices. This means that certain features might not work as expected on all supported platforms. Apps perform well during tests, but failing in the hands of the users is a common scenario. So, and the fragmented nature of the leading mobile operation systems, especially Android, is a serious concern for developers. So different release dates, version support, and device also need to be considered on a regular basis. Enabling rapid tests and accurately predicting the app's behavior on each platform are the main reasons why this practice encourages the use of multiple emulators and, like I said, parallel tests and real device testing. So it was fast, but it has been fun. I brought a small conclusion here that continuous integration is vital for a health product, because it is a key component of this kind of evolutionary design ecosystem. So for CI to ensure, for continuous integration, to ensure that its apps are high quality and stand the test of time, it must aim to provide teams with fast. Your build needs to be fast to give a faster feedback, needs to be reliable, and we need to create a pipeline or build that are reliable. If you have flake tests or tests that are failing in constantly, you don't have a reliable workflow. And accurate and comprehensive feedback, it's important to, in order to rapidly correct or fast correct the errors in the pipeline, you have the accurate and comprehensive feedback to development cycle and enable the best quality apps deployment process. And that is, thank you. It's my contact here.
Great. Thanks for that, Aline. I thought that was a really awesome introduction to continuous integration and continuous delivery and how it applies on mobile. So yeah, I hope people can get in touch with you on LinkedIn. And thank you very much for your talk.
Oh, thank you, David. It was very fun. Thank you so much.